Introduction to SPSS and Data File Development. Methods of data collection: face-to-face interview, observation, record review, physical examination, data collection tools, questionnaire, coded or uncoded record sheet. Steps of data analysis. Data coding. If pre-coded questionnaire is not used, development of data file and data entry. Data cleaning, checking for errors. Data screening, checking for assumptions. Data analysis, interpretation of outputs, results. 3 questions for data analysis. What to do? What analysis shall I do? How to do? How to do the analysis using SPSS. What does it mean? How shall I interpret the SPSS outputs? We analyze data to answer the study objectives. SPSS stands for Statistical Package for Social Science. It is a strong, easy, and popular data analysis software. Commonly used statistics: frequency, central tendency, mean, median mode; dispersion, standard deviation range; SE, skewness; kurtosis, quartile percentile; trimmed mean, chi-square test, OR, RR, and 95% CLT test; ANOVA, correlation, and regression, binary logistic regression; non-parametric test, such as Mann-Whitney U test. Variable name: open the SPSS program. First job is to select a short name for each variable. You can give any name, but must be unique rules. Must begin with a letter, uppercase or lowercase, rather than a number. Cannot include full stop. Space or symbols, like retones, ML, etc. Cannot include words that are used as commands by SPSS, such as all, and, by, EQ, GE, GT, LE, LT, NE, not, or, to, with, etc. Development of a data file. String variable. Has the codes with letters, cho characters, like M, F, Y, N, etc. Numeric variable. Has the codes with numbers, e.g., 1, 2, 3, etc., or has the actual value, e.g., age of an individual. It is always better to generate numeric variable. Missing value. Missing value should be a value which is outside or the valid value. Dealing with missing value in SPSS. For example, we have conducted a study, and the study population was women aged 15 to 49 years. There are several missing values for age in the data, i.e., age was not recorded on the questionnaire, or respondent did not tell the age. First, we have to select a missing value for age. We can select any value which is outside the range 15 to 49 as the missing value. Say, we have decided to use 99 as the missing value for age. Now, to put the missing value for age in SPSS, use the following commands. Click on the cell under the column Missing. You will see a box with 3 dots. Next, click on the 3-dot box. Next, select Discrete Missing Values. Next, click on the left box. Next, type 99. Next, OK. Data cleaning checking for outliers. Outliers are extreme values that deviate from other observations. The outliers may appear in a dataset because of errors or variability in the measurements, errors in data entry, or other reasons. Most commonly used method to detect outliers is visualization of data. Some of the visualization methods that can be used are box plot chart, scatter plot, and histogram. Statistical methods like z-score and other methods are also available. Use the dataset. Data 3. Checking outliers. We will use box and plot chart to check outliers. To construct the box and plot chart for the variable systolic blood pressure, SPSS variable name, SBP, use the following commands. Analyze next, descriptive statistics next. Explore, next select SBP, and push it into the dependent list box next. OK. You can also get the box and plot chart using the following commands. Graph next, legacy dialogues next. Select simple next select. Summaries of separate variables. Under Data in Chart R, next, define next select SPP, and push it into the Boxes Represent box, next. OK. Checking accuracy of data entry. Use frequency, distribution for each variable. Assessing normality of data. Commonly used methods of checking normality of a dataset are through histogram and QQ plot, descriptive statistics, formal statistical test, Kolmogorov-Smirnov (KS) test, or Shapiro-Wilk test. Histogram. We want to know whether the variable systolic B SPSS variable name SBP is normally distributed in the population or not. We will construct the histogram graphs next. Legacy dialogues, next histogram, next. Select the variable SBP and push it into the variable box, next select Display Normal Curve, clicking at the box below next. OK interpretation. If we look at the histogram of systolic BP, it seems that the data is slightly skewed to the right, i.e., distribution is not symmetrical. QQ plot. To get the QQ plot for systolic BP, use the following commands. Analyze next descriptive statistics. Next QQ plots. Next select the variable SBP and push it into the variables box next. For test distribution, select normal, usually remains as default. Next OK interpretation. If data are normally distributed, all the points, dots, lie on the straight line. Note that our interest is in the central portion of the line. Deviation from the central portion of the line means non-normality. Deviations at the ends of the plot indicate the existence of outliers. We can see that there is a slight deviation of the dots at the central portion as well as at the two ends. This may indicate that the data may not have come from a normally distributed population. KS test and Shapiro-Wilk test. To do the formal statistical tests, KS test and Shapiro-Wilk test, to understand the normality of the data, use the following commands. Analyze next, descriptive statistics. Next, explore, next. Select the variable SBP and push it into the dependent list box, next plots, next deselect stem and leaf, and select histogram, next select normality plots with test, next, continue, next, OK interpretation. Look at the SIG, significance column of table. Here, SIG indicates the p-value is 0.000 for both the tests. A p-value of less than 0.05 indicates that the data have not come from normally distributed population. In our example, the p-value is 0.000 for both the tests, which is less than 0.05. This means that the data of systolic BP have not come from a normally distributed population. Recoding a variable. For example, you have the variable sex coded as M and F. You want to replace the existing code M by 1 and F by 2. There are two options for recoding of data. A. Recoding into same variable, and B. Recoding into different variable. Recoding into same variable, transform next recode into same variables next. Select sex and push it into the variables box next. Click on old and new values, next select value, usually default, under old value section, next type M in the box. Below, next type 1 in the value area, under new value section. Next click add, next type F in the value area, under Old Value section. Next type 2 in the Value area under New Value section. Next click Add, next Continue, next OK. Recoding into same variable. Recoding into different variable, transform next recode into different variables. Next, select sex and push it into Input Variable, Output Variable box. Next, type sex1 in the Name box and type Gender in the Label box under Output Variable section. Next click Change, next click Old and New Values. Next, type M in the value box, under the old value section. Next, type 1 in the value box, under the new value section. Next, click Add. Next, type F in the value box, under the old value section. Next, type 2 in the value box, under the new value section. Next, click Add. Next, Continue. Next, OK. Making class intervals, categories. We will categorize the variable age into the following categories: class intervals. Less or equals 20 years, to be coded as 1. 21 to 30 years, to be coded as 2. 31 to 40 years, to be coded as 3, and greater than 40 years to be coded as 4. Transform Next Recode into different variables. Next, select age and push it into the input variable, output variable box. Next, type age 1 in the name box and type age group in the label box under output variable section. Next, click Change. Next, click on Old and New Values. Next, select System Missing under Old Value section. Next, select System Missing under New Value section. Next, click Add. Next, select Range, lowest through value, and type 20 in the box below. Next, select Value under New Value section and type 1. Next, Add Next. Now select Range under Old Value section. Next, type 21 in the upper box and 30 in the lower box. Next, select Value under New Value section and type 2. Next, Add Next. Again, type 31 in the upper box and 40 in the lower box. Next, select Value under New Value section and type 3. Next, Add Next. Select All Other Values under Old Value section. Next, select Value under New Value section and type 4. Next, Add Next. Continue. Next, OK. Making class intervals categories. Find out from the dataset whether the age is normally distributed or not. Combine data into a new variable. We have defined hypertension as diastolic BP greater than 85 millimeters of mercury if it is a female, and diastolic BP greater than 90 millimeters of mercury if it is a male. Now, how to classify those who have hypertension considering the gender? To do this, first, we will create a new variable, say HTN, for which all the values would be 0. Use the following commands to do this. Transform Next Compute variable, next type HTN, in Target Variable box. Next, click in the box under Numeric Expression. Next, write 0, 0, using the number pad or keyboard. Next, OK. Combine data into a new variable. This will generate the new variable, HTN, with all the values 0. You can check it in the Data View option, the last variable. Now use the following commands. Transform Next Compute variable. Next, click in the box under Numeric Expression. Next, delete 0. Next, click 1 on the number pad or type 1 using the keyboard. Next, click If optional case selection condition. Select Include if case satisfies condition. Next, select DBP and push it into the box. Next, click greater than sign. Then write 90 using the number pad. Always use the number pad. Next, click ACAND on the number pad. Next, select sex.1 and push it into the box. Next, click on AT and then 1. Note, 1 is the code number for male. Next, continue. Next, OK. Next, SPSS will provide the message, Change Existing Variable. Next, click on OK. Combine data into a new variable. Transform Next Compute variable. Next, click If optional case selection condition. Next, delete 90 and write 85 for DBP, and delete 1 and write 0 for sex 1, since 0 is the code for female. Next, continue. Next, OK. Next, SPSS will give you the message, Change Existing Variable. Next, click OK. Thank you.